Hello everyone, and welcome to this next video in the Foundation module. In this video, we are going to have a look at how we can take our ground plane that we were working on in the last video, and how we can then extrude it upwards so we have the walls for our different floors, at least the start of them. So let's have a look here inside of our example file. What we're going to work on today is this section here. And I'm going to show you a couple of different methods, as well as introduce you to a couple of new concepts, so we are ready to start working on the later section down here, which will get a lot more complex. So again, we're going to take it somewhat slow, but I hope this will bring a lot of new ideas and concepts to you, and then you'll be ready for in the future videos. So let's get started. Okay, so let's get started on building the poly extrusion section. What I want to do is take these outer edges of my building and extrude them up. And for that, we need to use a poly extrude node. Now, let's go ahead and grab a line from the bottom of my polyfill. And I'm going to create a new section here on the left. Let's hold the Alt key. And if I then click in the screen, I will create a dot. And this will anchor the dot on my screen, so I can then pull data from that. Next, I would like to show you the poly extrude. So let's go ahead and create a poly extrude node. And the poly extrude is a very versatile, but also one of Houdini's more older surface operator nodes. And it allows us to take a surface, such as say a grid, and extrude its primitives up or in any given direction. So let's take this grid and let's give it 2 by 2 segments. Or let's make it 3 by 3. There we go. So now, if I look over here on its settings, we can see that we have a distance value. And if I move this distance value up, then the poly extrude node is going to extrude our surface upwards along, at first, its primitive or edge normal. Now we can also specify our own custom normals over here, but let's leave that alone for now. Next to this, we also have the ability to output the front, back, and sides separately. So right now, when you extrude it, it won't output the back, but if I turn this on, then we have a complete solid cube. And if we turn on the groups over here, we can also identify the front, back, and sides individually. So we can continue operating on those groups afterwards. So we could keep extruding, say, the front over and over and over again. Now, if we want to extrude this box in a very specific orientation, then we can also use transform extruded front. And this one allows us to set a world space coordinate, for example. So we can extrude this box upwards or sideways. So this can be useful if you need to have a very fixed orientation for your extrusions. And then last, up here, we have some other transformation options. So let's say we don't extrude our box, but instead we extrude it inwards. And if we increase this value, and we turn off the back, so we don't have two overlapping surfaces, then you can see how it basically allows us to create an inset into whatever surface we have. And as long as you don't have too many subdivisions that it has to collide with, you can do some pretty interesting things with this. Now, if you want to extrude based on the individual elements of our original source geometry, like every primitive of this grid, we can do that too. So up here, under divide into, we can switch this to individual elements. And now, if we lower our inset a little bit, and maybe increase our distance value, we can create this bricker pattern right here. Last, we also have the ability to add divisions to our extrusions if we want more divisions on our mesh. And we can also twist our meshes. I don't tend to use this too much, but well, you can do some interesting things with this. Now, the poly extrude node has a lot of other options as well. For example, we can extrude along a spline, we can output some UVs, but some of these elements I think are better suited for some other nodes, and we'll cover those in the foundation module as well. So for now, let's go ahead and continue. And I want to create a new poly extrude node, so I have a clean one. Let's create a poly extrude again, and let's drop it underneath this dot here. Now, at this point, what I want to do is take my edges here on the edges of my building, and as well as the surface, and extrude them up to the floor height of our building. So every single floor of our building is going to have a certain height, and then we're going to stack them on top of one another. So this is going to be one height of one floor. All right. Now to do that, we can take the distance value and we can simply extrude it. But I don't actually want to use this particular value because it wouldn't be quite safe. Instead, what I'm going to do is I'm going to use the transform extrude front. Now in the example project, I did this slightly differently. It was a bit more complicated actually, and I realized I don't need to go this deep, so I'll keep it a little bit simpler here. In fact, all we really need to do is extrude up the wall in global space up to a certain distance. Now I will link this up to some parameters later, so let's go ahead and color this one yellow so we don't forget. And I will call this one the poly extrude wall height or floor height. Okay. Now before we continue, I do need to make sure that our attributes are secure. And at this moment, they're not. And I'll show you what I mean. If you recall, I actually created a width attribute in a previous lecture. And this one's coming from my convert line node over here. Now, if I visualize this attribute, I can do this by going to the node and then go to the info button. And then in here, we can click on the width attribute. And this will visualize it in my screen. But at first, it's going to show up as a color marker. And I want to change this to a regular marker, so we see the numbers. Let me hide my primitive numbers, and then go to my main viewport and press D. And then in here, under the visualizer, I have my width attribute right here with this gear icon. This means it's created by pressing the button in the info panel. Then we can click on the edit button, and I'm going to change the type to marker. Now I'm going to leave everything else alone for now. But by doing so, we can now see our attributes, or rather our width attribute, these ones, inside our screen on the lines. And now that we know the width of each section, what I want to do is transfer this onto our extruded walls. So there lies the problem. The poly extrude is one of Houdini's older nodes, like I mentioned, and it does what it does very well, but it has some problems. It isn't very good at setting up UVs, at least not in my experience. There are other nodes that do this much better, and we will be using those later in the foundation module to supplement or replace the poly extrude. But it also has issues transferring regular attributes, like in this case. So to fix this, we actually have to transfer it from our original point here to the new mesh. So let's go ahead and create a null node first so I can show you the source geometry, which is of course our ground plane. And you can see how the actual center here does not have an attribute. Again, when we created this center shape, the attribute wasn't carried over. Not all creation nodes or geometry generation nodes do this. And when I talk about geometry generation nodes, I mean the polyfill creates geometry, and so does the poly extrude, and neither one actually transfers over the attributes in this case. So what I want to do to fix this is to create an attribute transfer. And if you follow the Houdini 101 series, then you'll know that the attribute transfer takes the attributes from input 2 and transfers them in world space to input 1. Now at this point we don't need its blending capabilities, but luckily by default these are turned off. Now first what we should do is configure the attribute transfer here, so it only transfers our desired attribute. So let's turn off the point attributes, because right now it's transferring every single attribute over that is on our geometry on input 2. And then under primitives, let's filter out just the width attribute. Now at this moment we only have the width attribute, so we don't really have to worry about this. But if you're ever using a node that transfers attributes, manage your attributes, because otherwise it might bite you later. Okay? Now as for the values or the conditions of this attribute transfer, right now they're set up mostly okay, but we do need to make some changes. Now, like I mentioned, the attribute transfer has the ability to blend. Now by default, the attribute transfer is trying to sample from just one place, the closest element that it's looking for. In this case, it's looking for primitives, because we're looking for a primitive attribute. And that's fine, because that means that this wall here, the center of this primitive, is looking for the nearest center of this primitive, and it finds it right below. And because it is extruded straight up, we don't really have to worry about this, because for every single one of these faces, this edge down below is the closest primitive to find. So it will always transfer the correct attribute. Now, like I said, right now, this is the closest point for this edge. And under normal circumstances, this will be fine. But if, for whatever reason, this center primitive here becomes closer to the center of these primitives than the bottom, then it would grab its attribute, and the wall value will become 0. So we have two solutions here. One, we can simply remove the junk data that's coming in here from our source input for the attribute. Let's call this null node the width attribute source geometry. Okay. And what we can do here is simply delete the front face. Now we already have a group on this, and that's the edge group. So if we filter out just the edge group and leave alone the face, then we won't have to worry about it transferring that 0 value at all. So let's go ahead and create a blast node and plug it in. And the blast node is a very efficient deletion node. And in this case, I want to filter out my edge group. And I want to make sure that we only keep that one. So I'm going to turn on delete none selected. And now I only have the edge of my building. And I no longer have that junk data that is the center of my structure. And I'm going to call this blast node the isolate edge. Now let's go ahead and give it a red color, because this node actually deleted something. And now it should always make sure that we do have the correct attribute. And you'll actually notice that the center is now also grabbing this attribute as well. I'm not going to worry about this right now, but that is something to consider as well. Basically, if you remove the geometry that it was originally grabbing its data from, then it will simply grab the data from somewhere else. Now there's one more thing we need to make sure we do, and that is to turn off the maximum distance. Because right now, if we extrude this building up to its top level, let's say over 20 units, then the center of these primitives is going to get too far away from the bottom line and will no longer transfer the attributes. To fix that, we simply have to turn off the maximum distance right here. Okay, so now that we have this, let's go ahead and set it to a more reasonable height. Let's say we make this a 3-meter high floor for our building. So this is going to be copied on top of one another, so we have different floor levels. But I do want to get rid of some of this other data around, because at this point we don't need this bottom edge, and we also don't need the top. Now, to get rid of the top, I can simply go over here and turn off output front. And when I do that, it will no longer generate the front side. But that still leaves me with the outer wall here. Now I do have the edge group that I could potentially delete, but what I want to do here is actually create a dedicated group for our walls and just call them walls. So over here on the side group, I'm going to turn this on and name it walls. And if I visualize my groups, you can see that I now have a walls group right here. And I'm going to create a blast node and simply delete everything but the walls. So I'm going to call this one isolate walls, color it red, and then up here I'll select the walls and make sure they're the only thing left. So delete not selected. So now I have this surface. I have my width attributes. And let me just clean up the unused groups as well. So we get rid of the edge group. And now we have a clean output for our walls, and they're nicely extruded up. Now when I mentioned that in the example project I did this slightly differently, let me quickly show you what I meant. Up here I had my simple poly extrude, but I was extruding it at a very small distance. Then I was taking an attribute transfer, like before, to transfer the width attribute over. And that was working fine. And I was transferring it at a very small threshold. This was a way to get around the issue that if there was another attribute somewhere, it would grab it. So in this case, I didn't delete the center primitive. It's still there, right? So in this case, I was only transferring at a very, very small distance. This would technically make sure that it wouldn't transfer anything else and only grab the closest edge on this particular wall. Like, it's very, very thin. I mean, you might be able to zoom in there and see it, but it will actually start clipping my screen. And then the next thing that I did was take the front group on my geometry, which I generated here, and then I extruded it upwards, or basically pulled it upwards because it already existed, using a certain distance value right here. And this would take the height of my floor and subtract the height of the extrusion. Now we'll go into expressions in a bit, so it doesn't really matter that we skip this, but I just wanted to show you why it's different in the example file, because I found a better way and I just wanted to show you right here. That's often what you do in Houdini. You might come up with one idea and then you get a different idea altogether, and it's like, why didn't I think of that earlier? It still happens to me as well. You'll just end up creating better code by doing this. The more you know about Houdini's nodes, the better you can make it. Now let's go ahead and select our nodes here. And I'm going to wrap these inside a net box. And I will call this one Extrude Walls. Let's make this a little bit bigger. Now the last thing that we need to do to finish up this part of the network is to add the height value for our floor to the top level of the tool. Let's go to our tool, right click on it, and then go to Type Properties. And then instead of grabbing the translate vector parameter here and dragging it in, I want to have just one float value that I want to assign to this extrusion here. So instead of doing that, let's go ahead and create a float value from the left. And I'm going to drop it on top of my building settings folder. And when you do that, it's going to put it below all the other parameters in the list. Then next, let's give it a name. I'm going to call this one floor height. And as for the name, let's just give it a nice name as floor height with some spaces and capitalization. Next, let's set up some values. Now, as for the floors, I don't want them to get too thin. I could limit the floors to say 2 meters, but in order to make the tool flexible for you to experiment with, I am going to put it lower. If you want to make a game-ready tool, I suggest you put it to certain limits that will be acceptable for your player character. Okay? And for now, I'm just going to put it at something that can be low, probably too low to play with, but at least you can try it out yourself. Then next, over here, we have the maximum value. This is going to be 10 meters, but I'm not going to lock it. Okay? Now, as for the default value, let's go ahead and set this to 3 meters. So we have a default of 3 meter high floors. Next, let's apply this, or accept. And I want to grab my interface, so let's open up the parameters from the tool. And I want to reference this from my interface. So let's copy the parameter and then plug it into the poly extrude right here. And we'll paste it as a relative reference. So with that set up, now if we go ahead and change the floor height, we can control it from the interface and everything's working properly. Okay, so that's this part of the network done. Now in this next section, I want to copy up my floors multiple levels. And there is an easy way to do it and a slightly more complicated way to do it. But I do want to show you both methods. And I'm doing this right now at the beginning of the lecture to get you familiar with the idea that there are multiple ways to solving problems. And knowing multiple ways will prepare you better for creating your own tools. So that's why I'm doing this, okay? So in order to do this, let's go ahead and create a copy and transform node first. And this is the easiest method. The copy and transform node allows us to take any object and copy it in any orientation or rotation and then duplicate it over and over again. So right now, if I were to grab my floor height, for example, let's go ahead and grab my interface. And then, let me just make this a bit smaller. Let's grab the floor height, copy that reference, and then I want to paste it up here into the copy and transform node and paste it as a relative reference. And there we go. Now we have a second floor. So you can see I can have one copy, that's one floor, 2, 3, 4, etc. Okay, so this is a very easy way to do this. If I press the D key and I quickly turn on or off my width, you can see that my attributes are also being transferred over. Now, I do want to have a couple of other attributes present here as well. One, I want to know the segment number, which is the number of the tile around the base. So if I look at the original tiles, you can see that they have these red numbers on them. Those are the primitive numbers, and those are going to be my segment numbers. As I go around the building, if I go back to, say, Unreal, for example, and I turn on my segment visualization, give it 1 second to cook, then you might recall that I have these numbers here at the bottom, and these represent the numbers of the bottom row of tiles. Now I can use this to identify each row in my building, each column of tiles. Now for that I need to create an attribute so I can read it back later, because the moment we start copying these tiles up, we're basically just going to start circling around the building. Again, if I hide my visualizer, you can see how it starts at the bottom, goes around the bottom edge, and then it keeps going around every single floor until it reaches the top. So like a spiral, basically. And the seam where it jumps up is going to be right here. Now I do want to be able to move the seam, but we'll do this in a later video. But for now, let's go ahead and create an attribute over here with an attribute create. And what I want to call this one is the segment number. Over here, of course, let's also call this one segment. Oh, here we go. And then as for the type, let's make this an integer. It will be a primitive attribute. And if I plug it in, let me just clean this up. Here we go. Then down here, now in my spreadsheet, you can see I have a segment attribute available. Now I want to set this up so every single primitive gets its own number. And to do that, we can use one of Houdini's default variables, or local variables. And we can type that in using $PR. And this will grab the primitive number. And this only works on a select type of set of nodes, specifically the ones that loop over every single element in our geometry. And the attribute create does that. It runs over every single primitive, in this case, and it grabs its primitive number when it runs over that, and then it assigns it as the value for that attribute. Here we go, so now we have this as an attribute, and let's go ahead and visualize that. I'm gonna hide my primitive numbers for a minute, and then let's click on the node, go to segment, And by default, it's gonna color them again. So we can see that every single column has its own color, meaning its own value on the attribute. And then I'm gonna change this to a marker. All right, so now it's working. Every single column now has its own attribute. So that's great. And the last thing that I want to do is get my floor number as well. And we can do this very quickly by going over here into the copy swap, the copy and transform node, and then we have the copy number attribute. If we turn this on, and I'm gonna call this one floor. Then likewise, if we visualize this, then now you can see that every single floor has its own attribute as well. And that's pretty useful. Let's go ahead and turn this over into a marker as well. So let's click on that, switch it to marker type, and you'll now notice that your markers are getting a little cluttered. It's hard to recognize which one's which. I mean, you have to look closely. So I'm going to change the color as well. Let's call this one green. Okay, so at this point we have what we need in order to continue. But I do want to show you one other way to replicate the same process in a slightly more manual approach. And this is useful because the copy and transform node just copies what we had at the bottom floor. It doesn't allow us to customize whatever data is inside, and it's a bit more limited in that way. So if we want to make sure that we can actually set some attributes on these floors for whatever reason, we need to actually wrap it into a loop and replicate the behavior of the copy node ourselves. So I'll quickly show you how to do that next. So the next thing I need to explain to you is two different things. I need to explain to you how we can create a for each loop to replicate the behavior of this copy node, and I need to explain to you the concept of attribute referencing. Now let's start off with the for each loop. Now this copy node actually acts like a for each loop in some kind of way. Basically, it grabs whatever we have and then it duplicates it and applies a transform to it. And every single iteration is getting that transform. If I apply a rotation, for example, I can actually rotate the individual parts of my building and create a much more interesting shape. But that's not what we want to do here. Now, in order to apply our own transform for each loop, we need to go ahead and create a for each node. And the for each node, or rather the for each block in Houdini, is a combination of nodes that get placed when you create one of these types of nodes. Let's do that. Let's go ahead and press tab and look for each. Now there's actually also a for loop with feedback available, but I'm not going to dive into this one right now. So let's look for each. And here you can see there are 5 different ones. Now in reality they're all the same node, but these are just different presets for that node. So if we press one of these, we create a fully pre-configured for each loop that we can start working with. Now the one that we want to use is the for each one by number. Now we can also run it over primitives or points, or over objects with a particular attribute. So every unique attribute gets processed. And the last one here allows us to loop over every connected piece. So every piece of geometry that's connected. And each one of those has its own functions. And we'll use some of these here in the foundation course. But for now, let's start with this one, the for each by number. And if I drop this one down, you'll see that we get this little wrapped network. And this basically means that all these nodes are linked together. If I grab my view and then I go to show the dependency links for my selected nodes, and I grab these nodes, you can see that they're actually referencing each other. These nodes are interconnected. So whenever you create a for each loop, I suggest you don't break it apart, right? At the very least, for each loop needs a begin block and an end block. And then the end block has a series of configurations on it that we can set. Now in our case, this one is already configured correctly. What this loop will do is it will take whatever we give it, and then it will run over it 10 different times based on the iteration value right here. If I reduce this, then now it will run 2 times or 3 times. Very similar to what the copy node is doing. It's running a certain amount of times over our original geometry, and then it's transforming it in the process. Now a for each loop will take whatever you feed it, and it will process over that geometry. In this case, we are running a certain amount of times, so it will take whatever we feed it and effectively duplicate whatever it is that amount of times. If I give it a grid, for example, and I feed it that, let me go ahead and set this to 2 and 2, and then we look at the primitive numbers. Then you can see that under the primitive numbers, I actually have multiple primitives. For every copy, it's going to add 1 more primitive. So this is another way to effectively duplicate your geometry. Now you'll also notice that there's another block right here. And this one is another begin block, but it's actually set to fetch the metadata of this loop. And metadata of a loop basically just means that it has a detail attribute describing the current iteration that this loop is on. If I select the end block here and I go to single pass, and I need to make sure I'm actually displaying this node, so let me go ahead and pin that. Now if I move the single pass number around, notice how in the corner the iteration value is reflecting our current loop iteration. And up until the point that it runs out of loops, because the moment we go over the maximum iterations right here, this will stop generating geometry. So for every single one of these 7 loops, it's going to generate a piece of geometry, and in that loop, this node will output which loop it is in. Now what we want is to sample from this node the current loop when we're processing that particular loop, and grab it and put it on our geometry. Alright, so let's go over to my drawing board and let me show you what I mean. So here I have a representation of my current floor. So if I just quickly show you, it's like this, right? We have our floor, it has a height value coming from our parameter down here. So let's say we have a height value right here, representing the height of our floor. Let's call this one h. Okay, height value h. Next to this, we also have the iteration for our current copy. So that would be iteration value y. Okay, so every single time we make a copy, we iterate this number up, and it starts at 0. So the first one, the first floor, is going to have y value 0. Okay, and that means that if we multiply the height by the current iteration value, it's going to stay in place. It's not going to move. Now, if we have more iterations than 1, let's say we have an iteration 1 and then iteration 2, then each one of these is going to multiply the height of our position up by that amount. So in this case, that would be the height multiplied by 1 is, in this case, let's say 3. Okay, so if the height is 3 meters, then it's going to become 3, and it's going to move this floor up by 3 units. And 2, of course, is going to make it 6. So if I apply that concept to my building over here, and I grab, let's say, the segment number node, and I plug it in instead, and I run it over, I don't know, 3 iterations, then right now it's going to just duplicate them all up at the same level, because we're not transforming it at all. So to fix this, what we can do is add a transform node. And this transform node is going to allow us to move our floor up by a certain amount for that particular iteration. if I grab my block here at the end and I make sure that the iteration is set to, say, 1, then what should happen is that we will take the height of our floor and we will multiply it by the iteration value, and then it will return a value of 3. So in this case, what I can do is go up here to my translate channel, and under the Y channel, I want to write a little expression. Now first, I'm going to need the height of my floor. So I can take it right here from the bottom and grab the floor height. Let's copy that parameter and paste it in here as a relative reference. Then, next what we want to do is expand upon this expression, because right now we are copying all of our floors, every one of the copies, up. So in this case, I want to multiply it by the current iteration that we're running over. And I can visualize this very easily by grabbing the single pass attribute right here, referencing that, and then I'm going to plug it behind my floor height channel reference, and I'm just going to multiply these two. Now this isn't going to do what we want it to do, but it will show you what I mean. So right now I have linked up this transform node to the attribute here, and if I increase my value, assuming of course we have enough iterations to copy, it will move this floor up for every iteration that we do. But I wanted to do it for every single iteration, because if I turn this off, then every floor will just be at that height, right? So this won't work. What we need to do here is link this part of the expression up to that node, the begin block, because the begin block knows what iteration this loop is in. So if we are inside loop 1, then we get iteration 1, and then we need to retrieve it on the transform node. Okay, so simple enough. To do this, we need to use a attribute reference. And let me quickly explain what an attribute reference actually does. The one we want to use in this case is the detail attribute reference. Let me grab a notepad over here. And the detail attribute reference allows us to grab an attribute from another node of a certain type. So in this case, the detail attribute reference grabs the detail attribute. And we can reference another node very simply by first typing its address. So we can type within quotation marks // to navigate up out of this node, because we are of course on a parameter, and if we don't navigate up, then we will still look inside of the interface of that node. Instead, what we want is we want to go up into the network into this level where all the other nodes reside. Then we want to type the name of the node we are trying to reference. In this case, we are trying to grab the for each count 1. So let's say it's for each count 1. And that will then tell this expression to look for this attribute on that node. Then we want to tell it what attribute to reference. In this case, we need the iteration attribute, as you can see down here. So let's type that one, iteration. And then the last value that the detail attribute needs is the index of the value. Now that's for if you say have a vector which has 3 values, or if you have an attribute with a larger size, like a size 5, which has 5 values. Well, in this case, we want the first one, which would be 0. But of course, the iteration attribute only has 1 value, so this will be fine. So if we have this, and we use this expression, then it should work. If I copy this, I paste it in place of this channel reference here, then now you notice that it has created a link between this transform node and the for each count begin block here. And now if I turn off single pass and I look at every single iteration, now we are copying our floors for every layer. Alright, great. So at this point, this is working. right? We're basically using the detailed expression over here to reference the iteration number from this begin block, and then for every single iteration it is going to copy that floor up. Now we can use this to do all kinds of other tricks. By referencing the iteration number, you can make it do rotations, you can know which layer you're on, so you can filter out specific layers and only color those, for example, with say an if statement or whatever condition you're trying to set up. But in this case, this is enough. However, there's one more thing I want to show you, and that has to do with creating spare inputs. And a spare input allows us to reference a node with a negative number. So let me show you what I mean with that. Let's say we have a subnet. And this subnet by default has 4 inputs on it. Now Houdini expressions can reference an input by their number. And the inputs on this subnet rank from 0 to 3. Okay, left one is 0, then you have 1, 2, and 3. And that's pretty simple. So let's say I create a parameter on this subnet. Let's say I create a float, right? Just hide all these labels, get them out of the way. And right now, if I were to plug something into this subnet, like let's create an add node. The add node allows me to create a single point, for example. I'm just going to turn this on. There we go. We have our point. Let me plug this into the first dot on the subnet. Now I can reference whatever is on this point from my parameter really easily. And let's count the number of points that we have. So I'm going to add a couple more points here. Let's add 3 points. Okay. And I'm just going to position them. So you can see we have 3 points right there. I'm going to use a number points expression, or endpoints. And endpoints allows me to sample the amount of points that the expression receives. So in this case, if I type 0 inside the field, it's going to reference the input 0 from this subnet. So whatever this particular node or container or subnet has as an input, it's going to reference that, input 0. Now, if I look under the result of the expression, you see it's 3. Okay. Now let's say I grab my add node and I make a copy. And I plug this into input.1. Let's go ahead and remove 2 of these points. So we only have 1 point remaining. Now on my subnet, let's change the expression to reference input 1. And now you see it's only grabbing 1 point because it's referencing this node. And you will see the link that's being created here from the add node to this node, because this expression is asking for the input of my subnet. Okay. Now let's say I have a lot of these inputs. Let's say I have too many inputs, right? And I want to reference another one. Well, I can't do that because I ran out of dots, right? I ran out of inputs. This one could have, I don't know, 4 points, and I can't reference it because I can't plug it in. Now I can fix that by creating something called a spare input. And I can do that by going to whatever node you want to add one to, and click on the gear icon, and then click on add spare input. And what this will do is it will basically create an extra spare parameter of some kind that specifically can be used to reference another node. And that node can then be referenced as a number. Now to do that, I can of course just type the address. So in this case, let's go ahead and type / add 5. And there it is. And now you see how it's created a link to this node. Plus it's created this little dotted purplish blue line. And this one means that this node is currently being referenced by a spare input. Now, when we create a spare input link like this, the node that's being referenced will be referenced as a negative number, starting from -1. So spare input 0 is going to return this particular node as -1 as an input. So if I change my number points here to -1 instead of 1, then now it will return 4 points, because this node here has 4 points. If I disable this node, it no longer outputs any points, so it returns 0. So you can see that it is working, right? This is a link, a spare input link. And there are a couple of benefits to creating spare input links. They make your expressions a lot simpler, because if I can reference my for each count node right here through a -1 number, then I don't have to type as big an expression. Let me just pull this up, and instead of typing all of this, I could type -1, right? That makes this a lot simpler. But if I were to do this right now, it wouldn't work, because I haven't set up my spare input yet. It will tell me there's an error. So let's go ahead and do this. I'm gonna just delete this stuff. And let's create a spare input on this transform node, so we can sample it from the count node over here. Let's add a spare input from the gear icon, and then reference my for each count node. So I'm just going to copy its name, go to spare input 0, type $/, and then plug it in there. And now we have created our spare input link, and the expression can now evaluate. So if I look at the result of the loop, voila, now we actually have our stack of floors. Everything is now working. Now, there's one more thing I want to do, of course, and that is to set up the floor copy number. As you recall, our copy node actually outputs the current number of our floor. So in order to do that, we need to also sample our current iteration number from the loop and bring it over here. And we can do that, of course, using an attribute create node. Let's go ahead and do that. We can plug this in like so. And I'm just going to give these some names quickly. So this will be my floor number. And this I'm going to call my offset copy, because it will offset the copy that we're making. Now, under the attribute create node, let's go over to the gear icon, click on add spare input. Then we want to copy the name of this node, or copy the file path from the transform node, and just set it up. So we're referencing it like so. Now at this point, we could just go ahead and copy the detail attribute reference from our transform node, copy it over, and then paste it into the value field. Now we have our attribute being referenced, and I just want to make sure it's set up properly. So let's make sure it outputs a primitive attribute. It is an integer attribute, and I want to make sure it's called floor. Okay, so at this point, our loop is basically doing the same thing as what this single copy node was doing. But like I mentioned, the reason that I wanted to show you how to set up a loop is to show you the different things that we need to do later when we start making our tiles. And I'd rather do it now when it's simple, rather than have to show you when it gets complicated, right? So later on I can just breeze through this part, because you know now how to do this. Okay, so at this point, we can continue with either one of these setups. The only thing that we need to do here is make sure that we have an parameter on our interface to link it to. So let's go ahead and do that. Over here on the for each block, I'm just going to give this a name as well. Let's call this floor, and I'm going to copy this to the first part as well, so we know which one this is. And then let's go and open up my type properties, and I'm going to grab from my copy node over here the total number value. Now it doesn't matter if you grab it from this or the for each block. I just need an integer, so let's plug that in. And I want to call this one not NCY, which stands for number of copies. I want to call this one the floor count. And the same thing for the name. Okay. Now as for the values, this is fine by me, but let's go over to the channels and set the default value to, let's say, 4 floors. Whatever amount of floors you want your tool to have by default, do that. I do advise you not to set it too high by default, because the tool will slow down if you make your buildings bigger. So having a really tall building is going to have a lot of tiles, and that's going to be slower. So we are going to keep this somewhat manageable for starters. When you're happy with this, go ahead and click apply. And now we will have linked up our copies to our copy node. So if I move my floor count, we can now build a taller building really quickly. Now you can still see that I can actually bring it down to 0, and I don't want that. I want to have at least 1 floor. So I'm going to go back, and I'm just going to set the minimum value to 1. Okay, so always test your tools, because you might make mistakes and leave something in there. So now we know for sure our building will not disappear on us. And let's do the same thing. Let's grab the floor count, copy that parameter, and then let's go to the for each floor end block. And then over here under iterations, let's plug it in there. Again, as a relative reference. So now this will do the same thing, right? So cool. Now we have the second part of our system done. Let's grab this set of nodes and put them inside of a net box, or we can press Shift O. And I'm going to call this particular net box the copy floors with numbers. Okay, so thus far we've talked about the basic poly extrude, attribute transfers, so we can transfer our width attribute right here. We've talked about using the copy node, and we talked about for each loops and attribute references. Now there are more types of attribute references that we can make, and I'll go over those as we get to them. For now, I just wanted to keep it simple. Let's move on to the next part, and that involves creating a group for the edges of our building. But we'll do that in the next video. Now go ahead and save your scene, and don't forget to also save your asset over here, and then I will see you in the next video. Thanks for watching this one, and have a good one.